Good morning, grade 8 students. In this session, we're going to continue with our chapter digestion, and in specific, we're going to talk about the enzymes for semester 3. In this session, we are going to continue to talk about the enzymes, the agents of digestion. We said that the enzymes, they are the biological scissors. They are needed to cut, to hydrolyze, to transform the food into smaller pieces. So we studied all the different enzymes. What do they do? Their different mode of action. How do they work in acidic medium, basic medium, or neutral? We said that every enzyme has a specific substrate. We said that all the enzymes, they work at 37 degrees Celsius, and we will discover why. So what are the conditions needed for the proper functioning of the enzymes? Application, we have to interpret the results of the experiment, and then we have to deduce the enzymatic properties verified in each of the experiment. Before we start, let's talk about interpret. What is interpret? It's analyze plus an indication. So this is the analysis plus indication, it's the interpret. So analyze plus indication, it's interpret. So whenever I ask you to have to interpret, you have to do analysis plus indication. Analysis alone, you won't get any mark. So pay attention to this. Let's start step by step with the first experiment. In this experiment, what do we have? We have in first experiment in the conditions. In document A, we have experiment is used to demonstrate a property of the enzyme, a specificity, and in figure B, we have the results obtained. So let's start step by step. In figure A, we have the two test tubes, A and B. Two test tubes A and B, they are found in a water bath. Water bath is like for example, a large beaker. It containing water, and the temperature is 37 degrees Celsius. In tube A, what do we have? We have cooked starch. So the substrate is the cooked starch. While in tube B, we have albumin of an egg. So here the substrate is the albumin of an egg. So this is the substrate. And what do we have next? We have fresh saliva in both tubes, A and B. So first, I'm going to repeat. In tube A, we have cooked starch plus fresh saliva. And in tube B, we have the albumin, and we have the fresh saliva. Albumin, as I said, it's a protein. Albumin of an egg, it's a protein. So what happened? We waited for 1 hour, and we see what happened for this. First of all, the first question I'm going to ask it by raising your hand, please. The first question is, what does the saliva contain? Which enzyme? Raising your hands. What does the saliva contain? Yes, Abbas.
Salivary amylase.
Salivary amylase, very good. So fresh saliva, it contains the enzyme salivary amylase. What is the substrate for the salivary amylase? Who knows? What is the substrate for the salivary amylase? Yes, Karim?
Starch, yes, does.
Very good. It works on starch. So it works on starch. Very good. So whenever it works on starch, Maya, what it will give? So salivary amylase, it works on starch to give what?
Yes, to give maltose.
Very good. What is maltose? It's a reducing sugar. Okay, thank you, Maya. So maltose, which is a reducing sugar. Now, in this experiment, we have in tube A and tube B, both of them, they contain saliva. And one of them contains cooked starch, and one of them contains albumin. What do you think? Where digestion occur? In tube A or tube B? Justify your answer. Don't look at the results before looking to the results. Yes, Hadi, do you have an answer?
Can you just...
Yes, Siri Najdi, do you have an answer for this?
Yes, أستاذ.
Okay, where does digestion occur? In tube A or in tube B? Justify your answer.
Something else.
Please, those who muted themselves without a permission, don't do this again, please. So, Celine, do you have an answer for this?
أستاذ I raised my hand بالغلط ما كنت ملاحظة.
I want you to answer this. This is your turn. I want you to answer this. Yeah.
أستاذ.
Please don't speak without permission. This is the third time I told you this. Raise your hand before you speak. Anyone is speaking without permission, I want to reply. Yes, Smile, do you have an answer for this?
Yes, Ustaz.
Yes. Where does digestion occur? In tube A or B?
Tube A.
Why?
Because it contains
Contains what? It contains starch. And
Starch,
saliva
okay.
contains salivary amylase that works on starch. That's why digestion will occur in tube A. So cooked starch is the substrate for the salivary amylase that is found inside the saliva. So saliva contains the salivary amylase that works on starch. So this digestion will occur in tube A, while in tube B, digestion will not occur. Why? Because fresh saliva contains salivary amylase that works on starch, and it doesn't work on albumin, which is a protein. So no digestion will occur. After 1
Okay.
hour, can't only say 7, here it's 8. After 1 hour, what happened? After 1 hour, the Fanning test, it gives a positive result with the tube A. What does this mean? This means that the starch was digested by salivary amylase into maltose. And this is a reducing sugar. Why do we do Fanning test? Do you see here? All the questions and all the lessons, they are related to each other. So here, salivary amylase digests starch into reducing sugar, which is maltose. This maltose will give a brick red precipitate with Fehling. That's why we have digestion in tube A. However, in tube B, there is no digestion. Why? Because albumin of an egg, it's a protein. After 1 hour, we did Biuret test. Biuret test is done for both proteins and or polypeptides. So we have violet color. So protein is still persist here. We have protein and it's not digested. That's why no digestion occurs in tube B. Only it occurs in tube A. This explains one of the property of the enzyme. This means that salivary amylase, it can digest only starch and not maltose. It can digest only starch and it cannot digest the protein, which is the albumin. So here, the enzyme is specific. What does this mean? This means that the enzyme, it works on a specific substrate. Let's do the interpret. After adding fresh saliva to the cooked starch in tube A, the result is a brick red precipitate with the Fehling. This indicates the process of reducing sugar. It's obtained from what? It's obtained from the transformation of starch in the presence of saliva. So starch is transformed in the presence of saliva. While after adding fresh saliva to albumin in tube B, the result is violet color with Biuret. This indicates that we have proteins and / or peptides in the albumin, and they are not transformed by the saliva. So here the enzymatic property, this is the first enzymatic property, number 1. Every enzyme, it works on a specific substrate. This is the first property. What does this mean? This means that the salivary amylase, it can digest starch into maltose, but it cannot digest albumin, which is a protein. So here the enzyme salivary amylase, it works on starch and not on protein. So in this case, enzyme in saliva, which is salivary amylase, can digest starch into reducing sugar, but cannot digest albumin, which is a protein. So this is the first property related to the action of the enzyme. Every enzyme works or acts on a specific substrate. This is the first property of the enzymes. Moving now to the second property. In this graph, what do we have? How many enzymes do we have? We have 3 different enzymes: pepsin, salivary amylase, and the trypsin. I'm going to ask the first question. Pepsin, it works in acidic, basic, or in a neutral medium? Raising your hands. Pepsin, it works in acidic, basic, or neutral medium? Yes, Ruwa.
Acidic.
Meaning that the pH greater than 7 or less than 7, Yeruwa?
Less than 7.
Very good, thank you. Salivary amylase, Gabrielle, it works in acidic, basic, or neutral medium? Neutral, meaning that the pH is around 7, يعني بين 6.5 to 7. While trypsin, yes, Celine Najdi, trypsin,
basic.
basic, meaning that the pH should be greater than 7.
7.
So this graph is showing the activity of the enzyme and the pH of the medium, meaning that the speed of the reaction. At this speed of the reaction and the action of the enzymes will be affected by the pH. Let's start first with the trypsin. With the trypsin, Yamaya, the pH, when it was about 1, the activity or the speed of the reaction was approximately null. It's 0.5. Let's see. When the pH increases from 1 to about 2, the activity of the speed of the reaction will increase to the maximum, and the activity of the enzyme pepsin increases to the maximum. So here at this pH 2, the activity of the pepsin is at its optimum. What the meaning of optimum? As its best, was best at this pH 2. While as the pH increases from 2 to 4, تقريبا approximately 4, the speed decreases back to the minimum. So here, if I ask you, I need new voices here. Adam Tairik, what is the best pH for the pepsin to work? What is the best?
استسمع سؤال.
What is the best pH for the pepsin to work? Which was the speed of the reaction was maximum? What is the activity of the enzyme was maximum? Here it's the activity was maximum. At which point? Here is the pH. At which pH? pH equal?
2.
Equal to 2. While at 1 and 4 it was minimum now. Okay? So what can we deduce here? What can this indicate? This indicates that as the pH increases, the activity of the enzyme increases, but to a certain limit, which is 2. So above 2, it will decrease, and less than 2, it will be minimum. Moving now to the enzyme salivary amylase. Who can tell me, Hali Hassan Basma, what is the best? Yes, Maya, you want to ask a question?
Sorry for interrupting.
Question?
I want to tell you, Ustaz, no, if you call me and I didn't answer, my internet is very bad.
No problem. No problem. It's okay. No problem. It's okay. If you have any problem, no problem. It's okay. Connection problems, it's okay. No problem. So, salivary amylase, the enzyme, Ali Hassan Basma, what is the best pH for the salivary amylase to work?
Salivary amylase?
Yes.
7. pH equals 7.
7, exactly?
7 or 8.
So. I don't think so. شوف, it's not 7. It's not 7. So it's less than 7. It's about 6.5 تقريبا. Okay? So it's about 6.5 يا علي. ماشي?
Okay.
Whenever it's less than 6.5, it was minimum, the activity of the enzyme, salivary amylase. When it's greater than 6.5, it decreases back to the minimum. So here, what is the best? It's 6.5. So as temperature, as the pH increases, the activity of the enzyme increases to a certain limit, which is 6.5. Since above 6.5, it decreases back to the minimum. Celine, do you have a question or you want to answer?
Want to answer?
Okay, yalla, wait, let's choose others and then we can go back to you, Celine. Let's give the chance for others. I need new students. Sabine Swaidan, what is the optimum pH for the trypsin? Trypsin enzyme, what is the optimum? Optimum meaning that the best pH. Yes, Sabine. What is the optimum pH for the enzyme trypsin?
Yes, أستاذ.
Yes, your answer.
Please ترجع تعلي السؤال.
What is the optimum pH for the enzyme trypsin? And what is the best pH? Where is the maximum speed here at this point? So now we can make a line downstairs. So it's about 8 to 8.5. It's the optimum pH, is the best pH for the enzyme activity. So it's the optimum pH. So here, let's make a conclusion here. First, before we make the conclusion, let's make the interpret. What did we say for the interpret? It's analyze plus indication. So let's start. For pepsin enzyme, when the pH was 1 in the acidic medium, the speed of the reaction was minimal. As the pH increased from 1 to 2, the speed increases from minimum to maximum. As pH increases from 2 to 3.8, it decreases back to the minimum. What does this indicate? This indicates that increase in the pH, it stimulates an increase in the speed of the reaction, but up to a certain limit. In this case, it's pH equal 2. So above 2, it decreases back to the minimum. Less than 2, it decreases back to the minimum. So the optimum pH is pH equal 2. However, for salivary amylase, for pH equal 5, the speed of the reaction was minimum. As its pH increased from 5 to 6.5. So 6.5, Ya Ali, we can say that it's in neutral. 6.5 to 7, it's in neutral. So the speed increased from minimum to maximum. And then, as it increases from 6.5 to about 9, it decreases back to the minimum. So this indicates that increase in the pH stimulates an increase in the speed of the reaction of the salivary amylase up to a certain limit. يعني above 6.5 بيرجع للمينيموم, less than 6.5 كمان minimum. So the best it's the 6.5 for salivary amylase. So لهلا هنا about two enzymes. First one is pepsin, the pH equal 2 is the optimum, and the second one pH equal 6.5 is the optimum. Third one for trypsin enzyme. Trypsin enzyme, it's for about 6 medium, the speed of the reaction is minimum. As the pH increases from 6 to 8.5, the speed increases from minimum to maximum. And then as the pH increases from 8.5 to 10, it decreases back to the minimum. Also the same indication, increase in the pH stimulates an increase in the speed of the reaction. كل ما زاد pH, كل ما زاد speed, but up to a certain limit. This limit here is 8.5. So this is the 8.5. So here is the second enzymatic property. Enzymatic property number 2. Every enzyme needs a proper pH. يعني every enzyme needs a specific pH to work. يعني pepsin, it works only in acidic medium. Salivary amylase, it works only in a neutral medium. Trypsin, it works only in the basic medium. So here, the second enzymatic property, the enzymes need a proper pH. So till now we have two. Every enzyme needs a specific substrate. Every enzyme needs a specific pH medium. Moving now to the third experiment. Document D, activity on enzyme according to the temperature. So if I told you, Hadil, can you analyze this graph? Hadil Sufan, can you hear me? Hadil, can you hear me? Okay, she can't. Can you?
Yes.
Can you hear me, Hadil? Okay, Ismail, can you do this for me? Can you analyze this graph?
Yes, sisters.
Start from the beginning, Ismail. At temperature 0, the activity of the
Okay,
enzyme was what?
At temperature 0,
0, yes.
0, 0 uh, 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 0
The activity of the enzyme was
0.
0%. Very good. As the temperature increases from 0 to about what? To about 30.
The activity of the enzyme increases.
Okay, very good.
About
So let's start step by step, Yasmail. At
Okay.
temperature equals 0 degrees Celsius, the activity of the enzyme was 0.
0.
As the temperature increases from 0 to about 37 degrees Celsius, the
Yeah.
activity of the enzyme increases to its maximum at 100%.
1.
Then,
Yes.
as the temperature increases from 37 to 60, the activity of the enzyme decreases back to
Decrease.
zero. So if I ask you, Hadil, what is the optimum temperature? What is the best temperature for the working of the enzyme? Yes, Hadil, what is the optimum temperature for the working of the enzyme?
Yes, I can't hear you well. My net is very, very bad.
Okay, I'm sorry for this. So Karim Zayat, what is the best temperature?
The best temperature is 37.
Very good. The best temperature, we can say it's the optimum temperature. It's 37 degrees Celsius. So the enzyme, they can work at their best at this temperature, which is 37 degrees Celsius. So this is the best temperature for the working of the enzymes. So for temperature, this is the interpret, Ismail. Analyze, that's indication. For temperature 0, the activity of the enzyme is 0%. As temperature increases from 0 to 37 degrees Celsius, the activity of the enzyme increases from 0 to 100. And as the temperature increases from 37 to 60, this activity decreases back to 0. What does this indicate? This indicates that as the temperature increases and they have increase in the activity of the enzyme, but up to a certain limit. What is this limit? Is the 37 degree. Above 37, the enzyme activity decreases to 0. Less than 37, also it will be 0. So what is the third property here? Third property, every enzyme needs a proper temperature to act. So till now, we have 3 different properties. Property number 1, every enzyme needs a specific temperature. Every enzyme needs a specific substrate. Every enzyme needs a specific pH medium. So 3 characteristics or properties for the enzymes. Every enzyme needs a specific substrate. Every enzyme needs a specific pH medium. And every enzyme needs a specific temperature, which is always 37 degrees Celsius. So optimum temperature is 37. Why? Because the enzymatic activity is at its best at this temperature. Inactive temperature. What is the inactive? The enzyme is inactive. What is the meaning of inactive? It's sleeping. The enzyme is not working. It's going to sleep. The enzyme is sleeping. It's called inactive. Is 0 because the activity of the enzyme is 0 at 0 degrees Celsius. لما تكون temperature 0, the activity of the enzyme was 0. So بنقول at 0 degree it's called the inactive temperature. While very high temperature, 60, 70, 80, 90, they are called denaturation or destruction temperature. Why? Because the enzymes will be destroyed at high temperature. So they can no more act. At 0, بيكون نايم. If I put the temperature 37, it can work again. But لما تكون temperature 60, the enzyme is destroyed. Even though I put temperature 37 again, it won't work. Why? Because the enzyme is destroyed. Yani enzyme is killed at this temperature. But you have to use the word denaturation or destruction. You have to use both of them. Okay? So here, temperature 37, it's the optimum temperature, is the best temperature. 0, it's called the inactive. And 60 and above, it's called denaturation or destruction. You have to keep in mind that if the enzyme was inactive, meaning that at temperature 0, -2, -5, like the freezer and others, the enzyme is inactive. But if we put it at 37, it can work again. However, if the enzyme was placed at very high temperature, meaning that 60 degrees and above, this enzyme, even though we put it at 37, it will not function because the high temperature will destroy this enzyme. So this temperature will be destroying the enzyme and the enzyme won't function again. ما حيشتغل ابدا. بينما اذا كان زيرو بيكون نايم، حتى على 37 بفيق بصحصح. إذا كان temperature high, the enzyme will be destroyed. The enzyme met, it's killed, so it won't function again, even though حطيناه at temperature 37. This is the worksheet that was for the last week to solve it. Consider the following experiment that aims to study the different enzymatic properties. We use salivary amylase as an enzyme, as bread, and an example about the starch. Pay attention here, please. We have 3 tubes, A, B, and C. So here in the first question, in tube A, bread plus salivary amylase. So the bread is the substrate, is the starch. Salivary amylase is the enzyme. pH, it's 7. Temperature, it's 37 degrees Celsius. After 6 minutes, the aspect or the appearance, we have 0% bread, meaning that no bread. They told me, interpret the experiment. Let's interpret step by step. I'm going to do the first, and I'm going to choose for the second and the third. In the first, what do you have to do? After adding salivary amylase to bread in tube A at temperature 37 degrees Celsius, where the pH equals 7, 0% bread was detected after 60 minutes. What does this indicate? This indicates that salivary amylase digested completely the bread. There is no bread since they are digested by salivary amylase. Moving for the second, tube B. I want a new voices. I want a new hands. Ali Fadi Basma, good morning.
Good morning.
Interpret the experiment in tube B, Ali. Yes, interpret the experiment in tube B.
In tube B, we had bread and pepsin.
No, we have to say after adding pepsin. Yes?
بس في ترجع تعيد ألف.
You have to say after adding pepsin to tube B containing bread.
After adding pepsin in tube B
Containing
on temperature 37,
containing bread. You have to say containing bread. Yes?
Containing bread on temperature 37.
You have to use degrees Celsius كمان يا علي, okay? 37 degrees
Yes.
Celsius, where the pH is equal to 7.
7,
Yes?
and after
60 minutes.
60 minutes,
What do we have?
the bread was
100%.
100%.
Okay, 100%, meaning that, do we have digestion of the bread? We have 100% bread. So the bread بعده مثل ما هو, doesn't change. So what do we have here?
Yes.
No digestion of the bread. This indicates that the bread is not digested. Moving now for experiment in tube C. Experiment in tube C. What do we have? We have I want a new word. Alma Audi, interpret the experiment in tube C.
Be in numbers and letters tube C.
Yes.
Do I interpret it?
Yes. After adding?
Okay. After adding bread and salivary
after adding
amylase
salivary amylase to tube C
to bread.
containing bread. Yes.
After adding salivary amylase to tube C containing bread at
Yes.
37 degrees Celsius.
Very good. At pH equal?
At pH equal to,
So
the iodine test came out positive.
positive. What does this indicate? We have digestion of bread or not?
This indicates that
Yes.
that starches what are present in the bread.
This means that the bread is not digested. We still have starch. So the bread is not digested. This is the indication. This indicates that the bread is not digested since we have a positive result with the iodine test. So they said specify the reasons why we don't have digestion. ليش ما صار في digestion in tube B and C? Let's see, who can tell me why there is no digestion in tubes B and C? Yes, Adam. In tube B ليه ما صار في عندي digestion? Can you specify this? Specify. It's on the rhyme of Wi-Fi, so we have to justify. Yes, Adam.
أستاذ عشان
English يا Adam.
because the pepsin إنه does not digest
Pepsin, it works on what? It works on a protein, and it doesn't work on starch. That's why there is no digestion. So here, every enzyme works on a specific substrate. Pepsin, it works only on a protein. That's why we don't have starch. However, in tube C, thank you, Adam. Thank you, Alma, as well. In tube C, we have a bread and salivary amylase. So the starch, and we have the enzyme. Temperature is good, it's 37, but here we have pH 2. So salivary amylase, it works at pH 2 in acidic medium? No, it works in a neutral medium. So it needs 7 as a pH. That's why we don't have digestion. So here you have to know the enzymatic properties, the 3. Every enzyme works on a specific substrate. Every enzyme needs a specific pH, and every enzyme needs a specific temperature to work on